Most scientific publications that use next-generation sequencing data submit to NCBI Short Read Archive, or also known as SRA. The first thing we are going to do is to go to NCBI to obtain raw sequencing data from SRA. So we are going to open Mozilla Firefox and search for NCBI. And we are going to search for a specific SRA, which is Quercus lobata TAC. We are interested in the SRA, and we are going to select the first one. And we are going to select on the run the SRR identifier and copy it. If you can't find the exact run, don't worry. I've included a text file with the SRR number for you to download. So we are going to use the prefetch from SRA Toolkit to obtain the SRR. So we are going to open the terminal. In this case is the Windows subsystem for Linux. But first we are going to create some directories. We are going to create using mkdir one directory called NGS course. We are going to that directory, cd change directory NGS course, and we are going to create a new folder called 01 raw. So make dir 01 underscore raw, and we are going to change directory for that specific folder. And we are going to use prefetch. So we are in 01 raw folder, and basically we are going to call prefetch from SRA Toolkit. We're going to pass the SRR identifier, and we want the output, so -o in the folder we are in, so dot. We press enter, and now we wait. So after downloading, now we want to extract the FASTQ files from the SRR. For that we are going to use fastq-dump from SRRA Toolkit as well. So, but first we are going to check if SRA is in the folder we want. So we are going to use list the files in our directory. So we have the folder SRR something something cd SRR, and we have the SRA file in that directory. So we are going to the previous folder, so cd dot dot ls. Okay, we are in the previous folder, and we are going to use fastq-dump. So fastq-dump split -3. This is to ensure that both forward and reverse reads from paired and sequencing are extracted. The SRR is in the SRR folder, so this one, and we want the SRR something something dot SRA, and we press enter and we wait. So the FASTQ files are extracted. Let's just check using LES. Here we are. The forward and the reverse reads. And let's look for a FASTQ file. So for that we are going to use head and 8, just 8 lines from one of the FASTQ files, and the output for mini.fastq, and we are going to open in Nano, which is a text editor. Mini.fastq. And what we have here is basically 4 lines for one sequence. And the first line is an identifier and starts always with an @ symbol. The second line is the nucleotide sequence itself. The third line is just a separator. Most of the times it's just a copy of the identifier. And the fourth line is the quality per base. About this, it is in ASCII code, and the ASCII code is for Phread. Phread is a score that tells how confident the sequencer is about each base. The higher the score, the better the quality. And the ASCII goes from exclamation mark to tilde. I'll just open this file just to exemplify. So the Phread scores are encoded, as I said, in ASCII, and they go from ASCII 33, that is the exclamation mark, to ASCII 126, which is the tilde. And in this example, the ASCII 126, the Phread score is 126 minus 33, which is 93. And this is why it is called the Phread 33 encoding. And this is default for most NGS tools. And this is basically it. And this was about the raw data. Next we'll learn about the filtering and trimming before alignment.